Okay, we wait for 1 or 2 minutes before we start. People are joining. So Suzanne has some technical challenges. So I will start with the opening slides. So this is a DNSOP interim meeting, February. Thank you for your participation and joining us. So I'm Benno. Tim and Suzanne are also remote in the room, available. Warren apologizes himself. He's our AD. And so the minutes, we will use the transcribe, and maybe some of us will also make some notes, but we will publish the transcribe as the meeting notes. Next, we are an official IETF session meeting. So the note well applies. Here are the RFCs and the BCPs that are relevant to know. We assume you are aware of the note well. We definitely want to share and make point attention to the IETF Code of Conduct. Briefly, all these points mean be nice and respectful to each other. We all do best and try to make our best effort to get good standards. Right, the meeting tips. This is the standard template we also use for in-person meetings. So we're all remote, so I don't need to give you any details here and suggestions. Well, mute yourself unless you want to talk and speak. The agenda for today. So we just did the blue sheets. Agenda bashing is now. For the next 50 minutes, Johan, Erik, and Leon will present a number of IDs, and with the IDs also the drafts that are under development, and one is already in last call, to come to a distributed multi-signer for the DNSSEC signing pipeline. So this will be about 50 minutes, and then we have a 10-minute open discussion. I understand that if there are some questions for clarification, so not a discussion, I think everyone can raise the hand and ask a question. Are you fine with that, Johan, Erik, and Leon? Yeah. Okay. So clarification questions are fine, but discussions really until the end. Before I open the floor to the presenters, Erik, Leon, and Johan, are there any questions, things I should have mentioned from the participants? No? Okay, excellent. I will bring up the slides over here and hand over and give you the token, Johan.
Let's see if it works.
Yeah.
Oh, it works.
Excellent.
Perfect. Thank you, Benno. And thank you everyone who is here for showing interest in this. This came about, it's not clear to me how it came about, but the underlying reason is at least that there has been a series of drafts by me and others in various collaborations over the past 3 years. And I came to realize that it probably wasn't really obvious to others how these things interconnect and how they sort of feed off each other and how they relate to each other. And I completely agree with and think that it's useful to sort of present all of it in context, all of it together, and that's what we're trying to do today. So this will be a couple of slides of retrospective in the start, and then we will move into the new stuff, and we will try to look for the, let's call it, common themes among these several drafts and common conclusions if possible, and we will see what happens after that. And I'm looking forward to everyone's questions. So with that said, this is where we started. We started with multi-signer, which is, using our definition, having multiple signers, but with the additional requirement that not all of the signers are run by the same organization. My view, or our view, is that as long as everything is run inside an organization, you can essentially do whatever you want. There are always solutions, etc. And we don't really need standardization, because standardization is what we really need for interoperability between entities. So anyways, this is our definition. Many others use the term multi-signer also for the case of everything being run by the same organization, and that's fine, but that's not the case we're looking at. This has certain consequences and implications. In today's environment and the way DNS works today, and this is sort of the point where I say that I'm really happy about the DLEG work, but this is for DNS without DLEG, and that has certain consequences. Obviously, the multiple signers must be able to collaborate, because they will actually have to share stuff. To make it operationally viable, it's necessary to also be able to deal with what we call onboarding and offboarding of signers by the zone owner. Say, I intend to go from having one signer to having two signers by adding this new signer, and that needs to be dealt with more or less automatically. Obviously, the collaboration needs to deal with, there is DNS information. DNS keys is rather obvious. Also, NS records is an interesting topic by itself. And finally, we need to sort out who is responsible for managing the delegation information in the parent. And all of this, again, just emphasizing that point, becomes interesting when this crosses organizational boundaries. So when I say short retrospective, where did we start with this? Well, we started with this in something called the multi-signer working group, and an offshot of that was a monolithic implementation of multi-signer. It's something called Music that some of you may have heard of. It essentially didn't go anywhere, and one of the primary reasons why it didn't go anywhere, in spite of working and all that, was that we came to realize that from a business point of view, it's not really a palatable solution to have an external third party, the multi-signer controller, be able to essentially insert data into my customer zone if I'm a signing provider that does this on a commercial basis to a zone owner. So the control function was sort of wrong in the monolithic design, and that has led to a rethink and a redesign. And then Peter Thomason and I started talking about this because we realized that we needed this notify DNS key thing to become aware whenever a signer introduces a new key, because that's something that needs to be picked up by the other signers so they sign a unified DNS key RR set, etc. And we thought about this, and we talked about it during the IETF in London. And long story short, this became the generalized notification draft and essentially the baseline for the desync record. In that draft, we focus more on notify CDS and notify csync rather than notify DNS key, just to start somewhere, and because those things were more, well, they had more immediate applicability to more people, and there was more interest for that. So let's not confuse stuff by going straight for the notify DNS key, even though that's where we actually started. And then we came to the rather interesting realization that this desync thing, it's great that we can signal stuff to the parent, but notifications are sort of just a rather blunt signal. It doesn't tell you much other than, please, Mr. Parent, you should go and look somewhere. Could we do something even more sophisticated here? And speaking with Mark Andrews about that, I came to realize, and I admit that I was unaware of this before, that, well, delegation synchronization through dynamic update is actually a thing, except it's a rather not very successful thing. The question is, why isn't it successful? And it seems that all the previous attempts, and there is a series of previous attempts, they failed for the same reason, more or less. And that reason is, well, to begin with, not knowing exactly where to send the update. And secondly, not really wanting to send the update to the name server for the parent, but rather somewhere else. And desync deals with both of these things. So I realized that we could make a fourth attempt. Nothing like trying the same thing again, except just change it a little bit. And that became the delegation management through DDNS draft. And it has been fully implemented, and it works nicely, etc. And I thought that was more or less a done deal from my point of view, except we started to notice a couple of things. And what we started to notice was that it's rather difficult over time to maintain state between entities if they are too loosely connected, if they don't have a sufficiently flexible communication medium to sort of check in with each other and make sure that they are on the same page and we are still in sync, etc. And with the dynamic update stuff between child and parent, we could end up in this state over time where the child lived a happy life believing that the parent trusted its key, and then 6 months later it actually needed to make a change, and it sends this change as a dynamic update signed by that key, only to at that point realize that the parent no longer trusts my key, or never trusted my key, or doesn't like me at all in general. So we needed something to sort out both bootstrapping mechanisms for keys, but also verifying that the key is actually in what state. And there are many different states for keys, not only trusted or untrusted, but other intermediate states. So we needed more communication here, and that became the key state draft that acts as a support infrastructure for the dynamic update stuff. And it's been documented. It hasn't been presented at IETF yet, because of agenda constraints, but it's also been implemented. And that sort of brings us back to multi-signer. And multi-signer, once we had those other things out of the way, sort of obviously start with the question of what is the mechanism for a zone owner to designate who should sign a zone. And once you have that, how should the different signers be introduced to each other, given that they need to somehow talk to each other and exchange information in a secure fashion? In the old centralized monolithic implementation of multi-signer, this was not a problem because you had this central controller entity, and the central controller entity talked to all the signers, so they didn't have to talk to each other. But in the distributed model, there is no central controller, and hence the signers need to talk to each other, and we need to sort out how to do that. And we have a proposal that we will introduce today based on a new record type called HSync. And the choice of mnemonic is obviously arbitrary, and we can change that to something else, but we choose that because this is sort of a horizontal synchronization. It's a synchronization operation between DNS providers for the same zone at the same level in the namespace. Unfortunately, this also had some certain problems with maintaining state over time, etc. And we ended up with a clone of the key state solution. So this is yet another EDNS optcode, EDNS0 optcode that we have specified, but we haven't implemented yet. So to say a couple of things about distributed multi-signer: no controller, no central controller, detection of changes to certain stuff, in particular the DNS keys. And we also wanted to have this outside of the signer if possible. So that led to what we call the MSA, the multi-signer agent, which is essentially a secondary to the signer that also looks for certain changes in the zone, for instance, changes to the DNS keys and certain other things. And then we had the old requirements that I mentioned a couple of pages ago, that the zone owner must be able to designate the DNS providers, and they should be able to locate each other. So here is an early architecture for this. We have the signer that gets the unsigned zone from the zone owner, signs it, zone transfer over to the multi-signer agent, and the multi-signer agent, for instance, may notice that, oops, there is a new DNS key here. The signer has initiated a zone signing key rollover, so there is a new zone signing key in the set. I need to immediately talk to the other MSA over here so that we can sort out that each of us publish the same set of keys and the world stays in sync. This model had certain problems, and one of the problems is over here, where you can see that, oh, by the way, I'm just assuming everyone can see my pointer. Yeah. Over here, we have a signer which has a zone coming in through a zone transfer. So it's technically a secondary, but it also has some sort of changes coming in either through dynamic updates or some API connection or something. And those two things don't necessarily play well together. So we realized that that's a bad design. We really wanted the changes to the zone that multi-signer synchronization processes force. We really want them to arrive upstream of the signer. But at the same time, we really want to have the changes arrive downstream of the zone owner, because we want to keep the zone owner not necessarily oblivious to this, but out of the operational complexity. Typically, he's buying a service and it should just work. We don't want to have him involved in the automated operation that happens all the time. And the end result is what we call the combiner. So the combiner is essentially a glorified zone transfer engine. It's a specialized piece of software that does zone transfer in and zone transfer out, but one more thing. It also does this management of a select set of Apex RR sets that it's allowed to replace with new versions that come from the multi-signer agent. And this is the DNS keys are managed through the MSA. The CDS record, if any, is managed through the MSA. The CSync record is managed through the MSA, and then also potentially the NSR set for the zone. So all of this come in up here, and the combined zone, which is what the zone owner gave us, plus these managed RR sets, are sent to the signer. The signer signs the stuff, sends it over here. He can verify that everything is okay. They can talk when needed, and it's also typically fanned out to various authoritative servers. So this worked better, and that brought us forward. But then we came to a discussion of this really changes what we call the source of truth for the zone. In traditional DNS, the source of truth is the zone owner. That's still true also with DNSSEC for the unsigned stuff. If you have outsourced your signer, then obviously the signer is, well, the source of truth for the DNSSEC data, because it generates keys and it signs stuff and adds RR6 and NSECs and what have you. And now we are making everything even more complicated by adding a third entity, the thing we call the multi-signer agent, that in addition to this manages these select 4 Apex RR sets: DNS keys, CDS, CSync, and the NSRR set. So now we have 3 sources of truth here, and that's obviously more complicated than before. And that brings me to my friend Eric, who will talk about the eDNS 0 changes that we have specified.
Thank you, Johan. Let's see if I get the slides. Yeah, I think I just got them. Perfect. So one of the drafts we have is the key state draft. And what is the key state draft trying to solve? So in the draft, automating DNS delegation management via dynamic DNS. The child are allowed to update their delegation information in the parent zone, secured with the SIG0 signatures. And now the parent needs to keep track of the SIG0 keys. And if the parent loses the key, or if the parent couldn't validate the key, there's no way for the parent to communicate this to the child. And the child will first be aware of this when it tries to do an update. Those too late. Entering key state instead. With this key state draft, we introduce a new eDNS option. This allows us to send the information both ways. We can ask the parent what the bootstrapping policies it has, if it can do automatic bootstraps, or if it must do a manual bootstrap. The child can ask the status of the key, and if something is wrong, it can upload the key again and do another bootstrap of the key. Or maybe it will set an alarm so someone can have a look at the problem. The key state option is modeled after the RFC extended DNS errors, but it's extended to the bidirectional. And it can signal more than just errors. For the distributed multi-signer draft, you also have a new eDNS option. It's similar to the key state option, what is used for signaling transport mode, synchronization model, and operations like hello and heartbeat messages, etc. And I think I'm going to hand it over to you, Leon.
Leon, you're still
You're muted, Leon.
Oh, yeah.
Ah, there we go. Sorry. Can you hear me now? Okay, I'll take that as a yes.
Excellent.
So,
Yeah, we do hear you. Sorry.
Yeah. So we're going to go through the HSync RR set to see what that can look like and the types of scenarios where we expect it will be used. So this is really for the horizontal synchronization, and then we'll see at the very end how it integrates with this delegation synchronization. So the zone owner is sort of, we want to minimize the amount of work the zone owner needs to do. They just want to get their zone signed. But the thing we ask of them is to publish this HSync RR set to signal sort of how the zone should be handled by these multi-signer entities. So for the zone in question, which is zone.example, we publish 4 fields, and that would be the state, and that's just basically turning on or off the entire thing. So you can sort of gradually on and most importantly offboard signers by just toggling them on and off. And then you have a column which is called name server management, which is indicating whether you, the zone owner, will be in charge of the NSRR set, or if you will allow the group of multi-signer agent to manage the name servers for you. And then you also have a sign column, which is indicating whether or not you want them to sign the zone for you and subsequently manage the DNSSEC related entries that is required. And then ultimately you have the identity of the actual provider, and they need to, this is how they find out about each other. And at the end of the slide, towards the bottom, you see an example of a configuration here with 2 signers, A and B. They are signing, but the owner is the one who manages the NSRR set. So in this configuration, they will only synchronize like the CDS post, CSync post, stuff that is needed for signing. And then at the very bottom, there's one provider that is assumingly being offboarded. So this will signal to the other providers that they will delete the related DNSSEC material from the zone so it can be properly signed. So this is confusing, of course, it's complicated. So we will look at some concrete examples and hopefully you will understand how we intend this to be used. So the very basic case really where we started is this: you have 2 signers that will sort of take full responsibility of the signing. And sort of in the topmost RR set there, you see then it's set that the zone owner is the one who manages the name servers. So that means the zone owner will need to know about the name servers that the providers use. And in the bottom case where it says agent, that means the zone owner is sort of letting the multi-signer agent, the MSAs, synchronize their name servers. So in that case, they will rewrite the NSRR set. So you see here, the signer to the left receives the unsigned zone via zone transfer. And first it goes into the combiner, which is sort of the injection point for updates we make. And then it goes into the signer, which of course distributes the zone to the name servers, but more importantly, to the right, it pushes the zone into the MSA. And that's when the MSA sort of finds out about these HSync entries, and it becomes aware of other providers that it needs to talk to. And so we can ask them questions like, what name servers are you adding, or what DNS keys do you have? And then once they agree on these RR sets, they update the zone through the combiner, and then that is ultimately what gets signed and distributed. So this is the sort of base case where we have proper full signers. We could also have something like this where we have one signer, but we have another entity which is not a signer but just a pure distribution provider that just has a bunch of name servers to help distribute the zone, but it doesn't do any signing. And in that case, it will not receive a zone transfer from the owner, but it will receive it from the signer. So it can distribute the zone. But it will still run, as you can see to the right, its own MSA, so that it can make the signer aware of its name servers, so that NSRR set can be properly signed. But even in this case, you could still sort of, the owner can still take charge of its own NSRR set, as you see in the topmost entry. So that means the owner will just have to know about these providers' name servers, and there's nothing to synchronize really for this and know that's the pure distribution provider. But if the zone owner, as in the bottom case, sets it to agent the hsync RR set, then instead it will sort of allow these name servers to be synchronized automatically. You could also have this case where the zone owner signs its own zone. That's sort of, now we're getting into more corner cases that we talk about, but basically the zone owner would have to sort of run its own MSA and sort of provide it to itself. And still you can have pure distribution providers as well. And in this, as in the previous case, it will still sort of take the zone transfer from the signer rather than from the owner server. And you can also have like a completely unsigned zone and just use it to synchronize name servers, which is sort of why we used to call this post M signer before, but then ultimately we moved away from the pure signing scenarios, and we now allow even sort of unsigned zones to synchronize their name servers horizontally, which is what we call it hsync. And you can even have, as the sign posts out here in the top node, you can have basically a no-op where you are enrolled in this scheme. You publish the hsync RR set, but you control your name servers and no one signs your zone. So basically it's a no operation, but it will still allow these MSAs to find out about each other and establish communication, but they will not issue any updates or anything like that. So you can sort of gradually enroll in this program in that way. So yeah, some security concerns here. Of course, you can just maybe not trust the other entities, and there are also some sort of invalid configurations to this hsync RR set that they need to be able to detect. And we also should ask ourselves, like, do we reveal any information here that could be sort of, since this is sort of made public in the domain name system, we need to ask ourselves, do we reveal any sensitive information here with these hsync posts? So, and that's, yeah, we really like to hear your opinions, but we believe we don't on these things. So yeah, for securing the zone transfer, of course, you can use TLS, but it's noted towards the bottom here, we don't actually expose any zone transfer sort of paths. We just expose basically these MSAs, but there's no telling sort of where they get their zone transfers from. So we believe it to be secure. And also, they need to talk to each other, these MSAs, and they should, of course, do so securely. And and that's sort of where we are at the moment. We have a sort of concocted a scheme where they can find out about each other and establish a secure communication using either DNS or an API like HTTP REST style communication to synchronize these RR sets that these HSync entries point out. So we have some examples of that here. See if I can click forward. So we have the owner and the MSAs, and this is the basic case. So both the MSAs, they get the zone transfer. And then what the quickest one does is it just queries these domains. From the HSync post, it sort of becomes aware of the domain of the other MSAs, and then it just appends these labels and looks up a URI, SVCB, and key posts.
Yeah.
And once it, yes, sorry.
I think in the because of time constraints, we need to condense this to we have lots of sequence diagrams. We've thought about this, and
you can take a closer look at them later.
Yeah.
But basically, what we intend to do is you look up these things, and then you send a sort of secured notify hello to the other one, and that way they become aware of each other, and they can start sending each other heartbeats to sort of know that they are up and alive. And then even in cases where there's a delay in the zone transfer, we still have a sort of way of making sure this turns out nicely. And also, if there's a kind of a race condition, they could still they will still eventually become aware of each other and establish this secured mechanism. And for the HTTPS case, it's basically the same, only they will look up slightly different post types, and then they will send it with HTTP instead. But the idea is the same. And now we're closing on towards the end. I think I will pass it to you, Johan, somehow.
Thank you. To me, this is really sort of the reason for this meeting. Is there a recurring theme of some sort here? And well, perhaps the focus. I mean, some of the drafts are infrastructure, like the various EDNS0 new opcodes and stuff, and the interesting drafts. Well, I think they're interesting, but that's obviously in the eye of the beholder. Are the drafts that deal with trying to solve some sort of problem that involves multiple organizations. In the case of automatic synchronization of delegation information, then the two organizations is the child or some sort of agent for the child and the parent, and typically they are not the same organization, and then automation becomes more complicated, and we wanted to find a way of fully automating that. And in this case, in the multi-signer case, or rather, let's call it the horizontal case, with or without signing. It could be no signing, single signing, or multi-signing, but it's also just one name server provider or multiple name server providers, and the name server providers may or may not be the same as the signing providers, etc. So there's a whole constellation of organizations that together help provide service for this zone, and that, well, or rather multiple things. And if these things are in multiple organizations, then suddenly the automation problem becomes much harder, and well, essentially it's not solved in a standardized way today, and that's what makes it interesting. So that's my takeaway of what the common theme is here. Automation of critical configuration stuff across organizations. So solutions then, well, we've added some stuff to the DNS, the desync record, possibly an hsync record. We've added several eDNS 0 options. So all of those are new things, new additions to the protocol. On the other hand, we also use 6.0 quite a lot. 6.0 is not for free. It has performance impact. But on the other hand, everything we do here is very, very rare. You don't change your delegation information every second. You don't even change it necessarily every year, but you could. And the same thing goes for the horizontal synchronization through hsync and multisigner. You don't add new keys every second. You add them much less frequently. So the cost of 6.0 is not really a problem for us. On the other hand, I will be the first one to admit that sometimes good judgment may have been lacking. There is a couple of record types now that we suggest that end in sync, and that is a bit much, but you just wait and see. We do have a number of open questions here, and one open question is why are we using DNS all the time? Why not just go for the API route like everyone else? And we can talk a little bit about that. We have certain requirements on the signer, although we are trying to make this design as, or we're trying to make the signer as multi-signer agnostic as possible. And we should talk a little bit about that. And then we should talk about using the MSA 6.0 keys for authenticating updates to the parent. And we should talk about authorization models. And we have a couple of slides for this. So about the DNS stuff, why are you guys using DNS so much? Well, we happen to like DNS, but apart from that, if you look at the hsync record and the hsync RR set, what is the advantage of having the zone owner designate its chosen signers and possibly chosen DNS providers through a record in the DNS? Isn't that something you just sort out through configurations that you cannot see, and you can see it, but the world cannot see it, and it's not public? Well, as long as you only have one provider, you're fine. But when you have multiple, stuff gets out of sync. And you have multiple, there is a major advantage in having this information published at exactly the same time to all of them, and that all of the involved providers have access to the same configuration information, or rather same declaration of intent, so that they at the same time see when something is, well, not good, rather than to be told individually and separately and not together. So that's a point with the hsync RR set, rather than doing it some, well, more traditional way. When it comes to the actual synchronization and the actual interaction between multi-signer agents in this case, or between the child agent and the parent agent in the delegation synchronization case, what is so very, very attractive here is that we have very, very loose coupling. It's rare that we need to talk. We have no performance considerations, and it actually turns out that the things that we want to do, typically notify the other party or change something in the other party, have absolutely excellent representation in DNS. Everything we want to do is easily representable in the DNS protocol. It turns out that the only thing that we were really missing was this maintaining state over time ability. That was one thing, and we solved that with the DNS 0 code. And the second thing that we were missing was being able to trust communication in both directions, and we solved that by signing the messages and also signing the responses. And so we'll see whether DNS is a good fit for this. We believe it is, but well, we will see. But if it isn't, well, guess what? There are hooks for API as an alternative mechanism, both in the delegation synchronization and in the multi-signer cases. So that's a question to ponder. Another question to ponder is the requirements on the signer. We've boiled it down to 2 requirements. The signer absolutely must be able to keep incoming DNS keys that in our case originate from other DNS providers, other signing DNS providers in the RR set. So it's fine that the signer adds its own DNS keys and keep track of those and roll them, all that stuff, but it must not drop keys that comes from outside. The second requirement is that a DNSX signer today typically does zone signing rollovers based on an internal clock. It considers that to be an internal affair. It will do key signing key rollovers in synchrony with the parent. It will, for instance, publish the new key signing key, and it will request a new DS, and then it will verify that the parent actually has published the DS before it takes the next step, etc. So there is a concept of requiring external confirmation before taking the next step in the rollover for the case of the key signing key. But we also need that for the zone signing key, because in a multi-signer context, if one signer introduces a zone signing key, that key really must be published and signed by the other signers before this first signer starts using it for actually signing stuff. So in a way, this second requirement is just a question of upgrading zone signing key rollovers to the same category as key signing key rollovers. They must have an external sync pulse before you proceed. However, the question is, are there any other corner cases we haven't figured out yet? So that's an interesting question. Yet another question that we're pondering is, well, in the delegation synchronization draft and code, we use a single key for the child, and the name of the key is the name of the zone. In a multi-signer context, or rather in a context with MSAs, where the zone owner is outsourcing operation and the MSAs take care of everything, it would be really, really neat to be able to have them also do the delegation management in the parent directly through dynamic update. The problem, though, is that their keys have names that are a reflection of their identity as DNS providers, not the name of the zone, the customer zone. And we haven't figured out a way to make that model be secure in relation to the parent. So my guess is that in this case, we will probably go in the direction of having each MSA generate a new key by the name of the customer zone, and then these different keys are all able to talk to the parent. But we haven't done that yet, but that's where we are thinking about it. Yet another question, and this is also about delegation management. If you look at this picture and we say that, okay, so something happens here, a new name server arrives on the playing field for some reason. We need to do an update here to the parent, and we send a dynamic update. Does this require separate authorization by the zone owner to allow the multi-signer agents, or whatever we call them, to initiate this type of communication with the parent, or is that already covered in the stuff that the zone owners already handed over to the signing providers? I mean, if you look at it from the point of view of interacting with the parent, in multi-signer you already interact with the parent because you are publishing, or we are publishing, CDS and C-Sync records, and then we're sort of just hoping for some sort of parent-side scanner to eventually notice. And everyone here knows how much I like scanners. But not doing that would probably not work at all. So is it different to allow your agents to use DNS update for delegation synchronization than to allow them to use CDS and C-Sync records for delegation synchronization? Or is it really the same? I don't know. Perhaps it's the same, but my fear is that people will think this to be scary, even though in essence it's the same thing. So it's at least worth discussing. And that's more or less it from us. And I wonder whether there are any comments or questions.
There are some in the chat. I don't know if we should start with those. Or...
So if I go from up here, I see Ed has a comment about sign, no sign would be more mnemonic than yes, no. I agree completely. That works fine. I mean, obviously in the protocol, this is a uint 8, so it's just an octet, and we can have whatever token we want represent the various numbers. I agree with sign, no sign. The model seems to be similar to multi-signer controller. Well, it is, except that there is no central controller in this case. From my point of view, if we look at this, the MSAs as a group constitute the controller. That's how I look at it, at least.
And the sort of protocol that we expect them to talk about, like sort of to actually do the controlling, that is also something we're working on, but it's not, we had other problems to solve first, I think.
Speaking of, and I see Stefan's comment here about RFC 8483 and coordinating through human means. Yes, I know. I mean, we have that inside organizations. For instance, it's rather well known now that .nz New Zealand has run a multi-signer configuration for years and years, but they do it in-house and manually. And of course, you could do it manually also across organizational boundaries. I'm not claiming that it cannot be done. I'm claiming it's rather difficult and potentially, I will not say dangerous. That's up to each one to judge. But I will say that the more complicated something is, the more attractive to actually find a secure automation mechanism for it would be. Steve has a comment about protocols are needed. Well, true. I mean, multi-sign has several uses, and the use of having two in an ongoing fashion, having multiple signers is of course just one case. Another case is that you have one signer and you want to get rid of him, so you onboard a second signer, and then you have two for a while, and then you offboard the first one. So that's yet another of the cases where you can use multi-signer. And in that context, let me also back up a little bit over here and and point at about 100 slides back. Over, well, something like here, for instance, that we have intentionally designed the HSync RR set in a way that it should be able to work both in a multi-signer context and a single signer context. Or incidentally, that was actually something we realized afterwards, also in a unsigned context. And the advantage of that is that suddenly adding an HSync record to your zone is not a binary transition, which is dangerous and scary, and you may not want to do it, because there are lots of ways of adding the first HSync or first couple of HSync records that are no ops. And then once they're there, you can flip one of the switches. And for instance, when everything in your infrastructure is working the way you want, you can flip a switch and say, now this one should start signing, or now they should start actually managing the NSRR set after I've managed myself for several years. So what else do we have?
I can say in comment to some of the chats that just popped up is that we have not really dealt here with the case of the MSAs actually talking to each other and saying, hey, I have this DNS key, you guys should add it too. That is sort of where we're sort of ending this presentation. Because it was sufficiently complicated to just establish a means of secure communication and becoming aware of the other providers. So it's not really, we haven't really dove into the sort of what they need to say to each other to actually agree, sort of become synchronized about the contents. But we are basing a lot of it on the sort of this multi-signer controller. There's a draft that sort of states what information needs to be added and removed from the zone in these cases. So we intend to have a protocol that sort of mimics that in a distributed fashion. But that is not really the scope of this meeting.
So I agree with that.
Oh, sorry. There's one question in the queue. So Ed is in the queue.
Oh.
And we can also have, well, after Ed's question, maybe go into Stefan's remark. Okay. If you're fine.
All right. Hi.
Hi, Ed.
One of the one use case I think that would be useful here is actually I should set, let me set this. In most of your use cases, you have the zone owner doing 2 zone transfers to 2 providers, not this slide. One of the other generic slides you have. I used to have experience where we had customers that would use us and a competitor, and they'd have to configure both of them, both the databases identically to get the same results of the two providers. Would you consider thinking about use cases like in this case you have now, a use case where the zone example unsigned, it just does 1 zone transfer to 1 provider, and then they figure it out themselves between the providers?
Like
that would
this
that would be expanding your problem set.
Yes.
I think that's a real use case that's needed in the industry.
I agree. I mean, we sort of came up with this one incidentally when we were sort of redesigning the HSync RR set, and we realized that if we just make sure that we have the right fields in the HSync R data, we can actually come up with a model that can sort of describe, at least I think so, every possible scenario. The thing we don't do, going back to your question, Ed, is that we do not in any way describe how the zone arrives at each provider. That has to be sorted out through contracts, through configuration, and outside of the HSync RR set. And The reason for that, and I've had questions about it, the reason for that from my point of view is that I don't want to tell the entire world exactly from which IP address the zone is transferred and exactly what IP address the zone arrives at, etc. Because the zone transfer chain is obviously a point of potential attack. So I think it shouldn't be made public. However, in a general sense, saying, me as a zone owner, I am using Cloudflare as a signer. That is not sensitive information in the same way.
Can I interrupt for a second? It's not the zone transfer chain that I'm after. It's editing the database that's driving all of this.
Oh yeah, I get that. That's absolutely fine.
So
More questions?
there were some questions. So we're at the top of the hour, but there is some discussion going on the chat. But it's for me difficult to distill a question from that. So,
I
thanks, Stefan. Thanks for helping out. Please go ahead.
Yeah, there is not a specific question because it's more an issue of in the future, should we care about that? I mean, should we add it as a requirement that the SOA has to be kept in sync? Then the second question is inside the SOA, what do we want to keep in sync? The email of the technical contact, the serial number, etc., etc. So I don't think we can give a clear answer now. Just that this is something to consider, that some of the Apex data may need to be synchronized or may not.
Yeah. I mean, we obviously, through this combiner thing, we've already identified several Apex things that absolutely need to be kept synchronized. I do not believe that the SOA is part of that, but obviously we could. But I hope that we won't have to. In my picture of how multi-signer works, if you have two signers that are completely independent, as in this picture, they will have separate SOAs. Full stop. That's okay. That doesn't cause a problem. The important thing is that they actually have the same DNS keys, etc.
I think that it depends on which part of the SOA you're interested in. I agree that the serial number probably do not have to be synchronized, but the email address of the technical contact, maybe.
I agree with that. Yes, of course. Those should be kept in sync, or rather, they should not be changed by the various signers. They should be kept in sync from what you originally got from the zone owner. So it's the serial number I'm talking about. More questions?
So it's also time, but I don't see us. Okay, Steve, please go ahead. No, sorry, we can't hear you, Steve.
No, we can't hear
you. It's not. I only can mute you, but I cannot unmute you, so it's not in my control. Yeah.
I see a question about TSIG. I would list TSIG as in how to secure the zone transfer from the zone owner to each provider and possibly other zone transfers in the system. Yes, of course you can do that. We secure that through TSIG, or you could use zone transfer over TLS or a VPN or whatever. They should be made secure. That I will say. Whether it's TSIG or some other technology is well, implementation choice.
Okay. Yeah. Thanks. And I think Steve is now. We can hear you, Steve.
Thank you. I'm sorry, I'm new at this highfalutin technology here. It seems to me the SOA question is arises only because we now have multiple sources of change or multiple sources of truth, and that when the natural updated interpretation of the SOA is that it's the SOA for the contents of the zone, not for the other additional moving parts, which are 3 in type. One is the number of providers, another is the set of name servers, and the other is the set of keys, each of which can be changed separately from the contents of the zone. So if anybody cares about having the equivalent of SOA for either of those, for any of those 3 different sets of data, have at it, but I'm not sure that it's necessary.
Yeah, I agree with that.
Okay, thank you all, and I'd like to thank you for all your attention. I'd like to pass on to Suzanne for summarizing and closing the session.
Yeah, sure. Can you hear me okay?
We can hear you.
Yeah.
Terrific, thank you. We did do, I just wanted to sort of tie it all together, that we did do this meeting largely because there's an integrated architecture, but there's been like 5 different drafts. Generalized notify is most of the way through the pipeline, but there are several additional ones that together are sort of the overarching architecture. And thanks to Jan and all of the draft authors for getting together on how to talk about these things as one view on how the workflow can work. It's hard to take something concrete out of the discussion yet. There's a lot to digest here, but we do encourage further discussion on the mailing list. And the other thing, I guess, is sort of a I don't know, point of process. We don't do it very often that we have multiple drafts that need to progress together, but this one might turn out to be one. You know, this architecture for multi-signer might turn out to be something where we have to keep multiple drafts in step if people decide we want to go through the process. So, go ahead and read drafts and bring questions to the mailing list and so on with that in mind also. Steve gets the last word, unless Benno wants it.
Well, it's not the last word because I'm going to ask a question. So, Suzanne, you make a good point. From your perspective, what would you say would be the criteria for reaching last call state? What work would everyone have to do in order to bring this up to the level that you and all of the leadership would be comfortable saying, now it's time to do a last call?
Oh, wow, that's way ahead. Because keep in mind that we are not terribly familiar with the integrated with the integrated architecture either. So I think that's going to take some discussion. The other thing is that the chairs don't decide that, the working group does. So if you have opinions, and I know Steve never has opinions, but we'll encourage him just this once. In fact, that's, obviously I would prefer, and I think we would all prefer to see technical discussion first, but there is a set of logistics about what documents and how they're put together that will need some additional attention. And I know that's a non-answer, but I hope it's at least a coherent non-answer.
Thank you.
Okay. Thank you all. I think we're, oh, sorry. So yeah, I want to close. So it's 5:10. Well, European time, sorry, Central European time. So are there's one final word one of the presenters wants to do? Johan, Erik, or Leon, before we close?
I have no more comments at this stage.
Excellent,
I'm
thanks.
really happy that you listened to this, and I hope you found it interesting. What should also be obvious is that while the delegation synchronization stuff is sort of cooked and works nicely, we are just in the initial stage of the distributed multi-signer stuff.
Yeah. Okay. So, oh, sorry, Suzanne.
No, just that this is the beginning of the path. This is a lot closer to the beginning of the path than to the end. So bring your, read the drafts, review the drafts, bring your comments and considerations.
Yeah. So thank you all. Thank all the presenters. Thank you all the participants. I'm sure we will discuss this further, one of the drafts at the IETF in Bangkok during the DNSOP, 2 DNSOP sessions on Tuesday and Thursday in the preliminary agenda. Thanks again, and see you either remote or in person in Bangkok. Thanks.
Thanks, everybody.
Thanks.
Bye.